I bet you didn't know that the deeper you go underwater, the harder the squeeze you feel. This sensation is due to the increasing pressure exerted by the water as you descend. When you dive into the ocean, the weight of the water above you starts to add up, creating a force that presses on your body from all directions. This is why divers often feel a tightness in their ears and chest as they go deeper. The pressure increases because water is much denser than air, and every meter you go down adds more weight above you. It's a fascinating phenomenon that showcases the incredible power of fluid pressure. Pressure, simply put, is the force exerted per unit area. Imagine a force being applied over a specific area. The larger the area, the less pressure you feel, and vice versa. This concept is crucial in understanding how pressure works in different environments, whether it's underwater, in the air, or within various mechanical systems. For instance, when you inflate a balloon, the air inside exerts pressure on the balloon's walls, causing it to expand. The same principle applies to car tires, hydraulic systems, and even the human body. Understanding pressure helps us navigate and manipulate the world around us more effectively. Imagine pushing down on a table with your hand, that's pressure. The force of your hand pressing down on the table's surface creates pressure. If you use more force or reduce the area of contact, the pressure increases. This simple demonstration helps us grasp the basic idea of how pressure works. It's the same principle that allows us to cut with knives, write with pens, and even walk on the ground. The pressure exerted by our feet on the ground allows us to move and balance. It's a fundamental concept that plays a vital role in our daily lives. The formula? Easy P equals F divided by A. This formula is a straightforward way to calculate pressure. P stands for pressure, F represents the force applied, and A is the area over which the force is distributed. By understanding this formula, we can predict and calculate the pressure in various situations. For example, engineers use this formula to design structures that can withstand specific pressures, ensuring safety and stability. It's a fundamental equation that has wide-ranging applications in science, engineering, and everyday life. Here, P is pressure, F is the force, and A is the area. This relationship helps us understand how changing one variable affects the others. For instance, if you increase the force while keeping the area constant, the pressure will increase. Conversely, if you increase the area while keeping the force constant, the pressure will decrease. This interplay between force, area, and pressure is crucial in fields like physics, engineering, and even medicine. For example, doctors use this knowledge to understand blood pressure and how it affects the human body. It's a versatile concept with numerous practical applications. In fluids, pressure works in all directions. Unlike solids, where pressure is usually applied in a specific direction, fluids distribute pressure evenly in all directions. This is why when you dive into water, you feel the pressure from all sides. This property of fluids is essential in understanding how they behave under different conditions. For example, in a swimming pool, the water pressure increases with depth, but it acts uniformly on your body. This uniform distribution of pressure is also why submarines and deep-sea divers need to be specially designed to withstand the immense pressures of the deep ocean. Dive into a pool and feel the squeeze. That's fluid pressure increasing with depth. As you go deeper, the weight of the water above you increases, leading to higher pressure. This is why your ears might pop or feel uncomfortable when you dive deep. The pressure difference between the water outside and the air inside your ears causes this sensation. Divers often need to equalize the pressure by pinching their nose and blowing gently. This simple act balances the pressure and makes the dive more comfortable. Understanding this concept is crucial for safe and enjoyable diving experiences. The deeper you go, the higher the pressure. This increase in pressure with depth is a fundamental principle of fluid mechanics. It's why deep-sea creatures have evolved unique adaptations to survive in such extreme conditions. Their bodies are designed to withstand the crushing pressures of the deep ocean. Similarly, submarines and underwater vehicles are built with strong, pressure-resistant materials to explore the depths safely. This principle also applies to other fluids, like air. As you ascend to higher altitudes, the air pressure decreases, which is why mountaineers and pilots need to be aware of altitude sickness and other related issues. The formula to remember? P equals HRG, where H is depth, RO is density, and G is gravity. This formula helps us calculate the pressure at any given depth in a fluid. H represents the depth, ρ is the density of the fluid, and G is the acceleration due to gravity. By plugging in these values, we can determine the pressure at different depths. This formula is particularly useful in fields like oceanography, engineering, and environmental science. It allows scientists and engineers to predict and manage the effects of pressure in various applications, from designing underwater structures to studying marine life. Ever heard of a barometer? It measures air pressure using mercury. Barometers are essential tools in meteorology, helping us predict weather changes. By measuring the atmospheric pressure, meteorologists can forecast storms, high-pressure systems, and other weather phenomena. The mercury in the barometer rises or falls based on the air pressure, providing a visual representation of the atmospheric conditions. This simple yet effective tool has been used for centuries to understand and predict the weather. It's a testament to the importance of pressure in our daily lives and how it influences the environment around us. And hydraulic systems? They use fluid pressure to multiply force like magic. Hydraulic systems are used in various applications, from car brakes to heavy machinery. By using fluid pressure, these systems can amplify a small force into a much larger one, making it easier to lift heavy objects or apply significant force with minimal effort. This principle is based on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. This allows hydraulic systems to perform tasks that would be impossible with human strength alone. It's a remarkable application of fluid pressure that has revolutionized many industries. So next time you dive deep, remember, it's all about fluid pressure. Whether you're exploring the ocean's depths or simply swimming in a pool, the pressure you feel is a direct result of the fluid around you. Understanding this concept can enhance your appreciation of the underwater world and the incredible forces at play. It's a reminder of the power and beauty of nature and how science helps us make sense of it all. So dive in, explore, and marvel at the wonders of fluid pressure. Stay curious and keep exploring. The world is full of fascinating phenomena waiting to be discovered. By understanding concepts like fluid pressure, we can unlock new insights and innovations. So keep asking questions, seeking answers, and exploring the wonders of science. Whether you're a student, a professional, or simply a curious mind, there's always something new to learn and discover. Embrace the journey of exploration and let your curiosity guide you to new horizons. Reading about fluid mechanics can open up a whole new world of understanding. Books and articles on this subject delve into the complexities of how fluids behave under different conditions. They explain the principles of fluid dynamics, the study of how fluids move, and fluid statics, the study of fluids at rest. By immersing yourself in this knowledge, you can gain a deeper appreciation for the science behind everyday phenomena. Whether it's the flow of water in a river, the movement of air in the atmosphere, or the circulation of blood in the human body, fluid mechanics plays a crucial role in our lives. In classrooms around the world, teachers are explaining the principles of fluid pressure to eager students. These lessons lay the foundation for future scientists, engineers, and innovators. By understanding the basics of pressure, students can build on this knowledge to explore more advanced topics in physics and engineering. They learn how to apply these principles to solve real-world problems, from designing efficient water supply systems to developing new medical technologies. Education in fluid mechanics is essential for fostering the next generation of thinkers and problem solvers. Hands-on experiments in laboratories provide students with practical experience in understanding fluid pressure. By conducting experiments, they can observe the effects of pressure firsthand and see how theoretical concepts apply in real-world scenarios. These experiments often involve measuring pressure in different fluids, observing the behavior of fluids under various conditions, and using pressure sensors and gauges. This hands-on approach helps solidify their understanding and encourages them to think critically about the principles they are learning. Engineers working on hydraulic systems apply their knowledge of fluid pressure to design and maintain these complex systems. They use their understanding of pressure to ensure that hydraulic systems operate efficiently and safely. This involves selecting the right materials, designing components that can withstand high pressures, and troubleshooting any issues that arise. Hydraulic systems are used in a wide range of applications, from construction equipment to aircraft, and engineers play a crucial role in keeping these systems running smoothly. In the medical field, understanding fluid pressure is essential for measuring and managing blood pressure. Blood pressure is a critical indicator of a person's health, and medical professionals use this information to diagnose and treat various conditions. By understanding the principles of pressure, doctors and nurses can accurately measure blood pressure and interpret the results. This knowledge also helps them understand how different factors, such as diet, exercise, and medication, can affect blood pressure and overall health. Environmental scientists study water pressure in rivers and other natural bodies of water to understand how these systems function. By measuring water pressure, they can gain insights into the flow of water, the health of aquatic ecosystems, and the impact of human activities on these environments. This information is crucial for managing water resources, protecting wildlife, and ensuring the sustainability of natural habitats. Understanding fluid pressure helps environmental scientists make informed decisions and develop strategies to preserve our planet's precious water resources. Even in space, fluid pressure plays a vital role. Astronauts experience pressure changes as they travel from Earth to space and back. Their spacesuits are designed to maintain a stable pressure environment, protecting them from the vacuum of space. Understanding fluid pressure is essential for designing these suits and ensuring the safety of astronauts. This knowledge also helps scientists study the effects of pressure changes on the human body and develop technologies for future space exploration. Scuba divers exploring coral reefs experience the wonders of fluid pressure firsthand. As they dive deeper, they feel the increasing pressure and must adjust their equipment and techniques accordingly. This understanding of pressure allows them to explore the underwater world safely and enjoy the beauty of marine life. Coral reefs are delicate ecosystems, and divers must be mindful of their impact on these environments. By understanding fluid pressure, they can minimize their impact and help preserve these natural wonders for future generations. Inflating a bicycle tire is a simple yet practical application of fluid pressure. As you pump air into the tire, the pressure inside increases, making the tire firm and ready for a ride. This everyday task demonstrates the principles of pressure in a tangible way. By understanding how pressure works, you can ensure that your tires are properly inflated, improving your bike's performance and safety. It's a small but important example of how fluid pressure affects our daily lives. Cooking with a pressure cooker is another example of fluid pressure in action. The cooker traps steam inside, increasing the pressure and raising the boiling point of water. This allows food to cook faster and more efficiently. Understanding the principles of pressure helps you use a pressure cooker safely and effectively. It's a great way to see how fluid pressure can be harnessed for practical purposes in the kitchen. Using a garden hose to water plants is a simple demonstration of fluid pressure. The pressure of the water inside the hose pushes it out through the nozzle, allowing you to direct the flow where it's needed. By adjusting the nozzle, you can change the pressure and control the water flow. This everyday activity shows how fluid pressure can be used to accomplish tasks around the home and garden. Flying a kite is a fun way to experience the effects of air pressure. The wind creates pressure on the kite, lifting it into the sky. By understanding how pressure works, you can adjust the angle and tension of the kite string to keep it flying high. It's a great example of how fluid pressure can be used for recreational activities and to explore the natural world. Swimming in a pool is another way to feel the effects of fluid pressure. As you move through the water, you feel the resistance and pressure on your body. This understanding of pressure helps you improve your swimming technique and enjoy the experience. It's a reminder of how fluid pressure is present in all aspects of our lives, from recreation to science and beyond. Reading scientific journals and articles about fluid pressure can deepen your understanding of this fascinating topic. These publications provide detailed explanations and research findings on how pressure affects different systems and environments. By staying informed, you can keep up with the latest developments in the field and apply this knowledge to your own studies or work. It's a great way to stay curious and continue exploring the wonders of fluid pressure. Conducting science experiments at home is a fun and educational way to explore fluid pressure. Simple experiments like measuring the pressure of water in a bottle or observing the effects of air pressure on a balloon can provide valuable insights into how pressure works. These hands-on activities help you see the principles of pressure in action and encourage you to think critically about the science behind everyday phenomena. It's a great way to learn and have fun at the same time. Using a microscope to study fluid pressure at a microscopic level can reveal fascinating details about how fluids behave. By observing the movement of particles in a fluid, you can gain a deeper understanding of the principles of pressure and how they apply to different systems. This knowledge can be applied to various fields from biology to engineering, and can lead to new discoveries and innovations. It's a reminder of the importance of curiosity and exploration in advancing our understanding of the world around us. Visiting a science museum and exploring interactive exhibits on fluid pressure can be a fun and educational experience. These exhibits often feature hands-on activities and demonstrations that help you understand the principles of pressure in a tangible way. By engaging with these exhibits, you can see how pressure affects different systems and environments, and gain a deeper appreciation for the science behind everyday phenomena. It's a great way to learn and have fun at the same time. Watching science documentaries about fluid pressure can provide valuable insights and inspiration. These documentaries often feature expert explanations, real-world examples, and stunning visuals that bring the principles of pressure to life. By watching these programs, you can expand your knowledge and gain a deeper appreciation for the science behind everyday phenomena. It's a great way to stay curious and continue exploring the wonders of fluid pressure. Discussing fluid pressure with friends and colleagues can help you deepen your understanding and gain new perspectives. By sharing your knowledge and asking questions, you can learn from others and explore different aspects of this fascinating topic. These conversations can lead to new insights and ideas and can help you apply your understanding of pressure to real-world problems and challenges. It's a great way to stay curious and continue exploring the wonders of fluid pressure. Conducting fluid pressure experiments in a lab setting can provide valuable insights and data. By using specialized equipment and techniques, you can measure and analyze the effects of pressure on different fluids and systems. This research can lead